Okay, this is Mark Anderson for Kellogg Community College. We're going to be looking at dividing polynomials by binomials. This is section 6.6 in Math 101, and this is going to be page 391, numbers 9 and numbers 13. So here we go. The original problem in the book is to divide x squared minus 3x plus 4 by the binomial of x plus 2. So what we're going to do is start our long division problem. We're going to make our long division bar. We got x squared minus 3x plus 4, and we'll divide that by x plus 2. To see if x plus 2 goes evenly into this trinomial, to get a little bit of perspective, we're going to check to see if this negative 2 is a solution to this trinomial that you might see on a graphing calculator. Okay, so we're first of all noticing this is this is a binomial, so it has two terms. So we're going to start this right there above the negative 3x. Now the first question I ask myself, what do I have to multiply x by to get a perfect match for x squared? And the answer to that is just an x. So now we do our distribution. This is going to be multiplication. X times x is x squared. And x times 2 is 2x. Now, what we're going to do next, like we do in long division, is we're going to subtract this from the one above it. So when I subtract, I'm subtracting the whole thing, so this becomes a negative as well. So we go down the top, x squared minus x squared, that simplifies to 0. Negative 3x plus a negative 2x is negative 5x. And then the plus 4 drops down like so. And now our goal is to try to see what will multiply by the x to make a negative 5x, and that's easy because that's a negative 5. A negative 5 times x is going to be negative 5x, and negative 5 times 2 is negative 10. We are then going to subtract this from the one above it, just like we would do in long division. So we put a subtraction sign there, and that would change everything here positive, or to its opposite symbol, I should say. And in this case, since both of these are negative, we're going to subtract a negative, which makes this positive. Distributing the negative over here makes that positive as well. The 5's simplify to 0. The 4 and the 10 make 14. Now, this number is our remainder. And it's our remainder in the problem, so what we will do is write our remainder like this. X minus 5 is what fit into this trinomial from this binomial. Then the 14 becomes the remainder. Now, normally we would write an R when you see remainders in long division, but with this trinomial, we would write it as x minus 5 plus 14 over what we were trying to divide by. And this is the answer to the problem. There are questions in the book and also models in the book that also show this, but I suggest rewinding the YouTube video and pausing it in certain places if you got lost or confused with any of these steps. Okay, we're about to move on to the next problem, which will have no remainder at the end. This is the polynomial with 4 terms, x cubed minus 6x squared plus 7x minus 2, all over x minus 1. Okay, so here's what we're going to do. I'm going to make a long division bar. We don't have to skip any spaces since all of these powers are descending by 1. We have a cube, a square, an x, and then no variable, or x to the 0 power. And then we have x minus 1. We're going to see how many times x minus 1 fits into this. Now you'll notice that this is another binomial. So we're going to put that right above there. All right. And I'm going to ask, what do I need to multiply my x minus 1 by to see how it works inside here? Well, I'm going to multiply my x minus 1 by x squared to get a match for x cubed. Because that's the one thing I want to ask. How is this term going to get multiplied to make this term? Well, x squared is the answer. So x squared times x is x cubed. X squared times a negative 1 is going to be negative 1x, or just negative x squared. Now we're going to subtract this whole thing from the binomial above it, put a subtraction sign there, and that, by subtracting this whole thing, flips that to positive. So these two simplify to make 0. Negative 6x squared plus 1x squared is going to be negative 5x squared plus, drop that down, 7x. Okay, so what do I need to multiply this x by over here to make this a negative 5 right there? Well, I'm going to need a negative 5 x to multiply by my x to get negative 5x squared. So here we go. Negative 5 times x is negative 5x squared. Negative 5x times the negative 1 makes a positive 5x. Draw a line. Now what we're going to do is subtract this whole line here. So we subtract, but that turns this positive, and that will make this negative here. Ooh, good things are going to happen. These two simplify to make 0. 7x and negative 5x make positive 2x. The minus 2 drops down just like that. Alright, now you see where I'm getting a little bit happy about this problem, because it looks like we're going to now simplify this so it will not give us a remainder. Because I ask, what do I need to multiply x by to make 2x? Well, I'm going to multiply by 2. 2 times x is 2x. 2 times negative 1 is negative 2. Check this out. I'm going to subtract everything here, changing the symbols of all my problems. Simplifies to 0, simplifies to 0. With no remainder, my answer to this problem is x squared minus 5x plus 2. And there it is. If you have any questions, email me through my Kellogg Community College email account or ask me questions on YouTube. Thank you very much.